Is it the radius, the force? The position from the ball to the center is the force, right?
Okay, let me draw it. There are two forces, only two forces. One is the weight, the gravitational attraction, the Earth, vertically downward. The second force is tension of the string. So that is vertical component here. When you resolve this tension into two components, the vertical component Ty, okay, will be equal to the weight. Not a good drawing, but the point is that they must be equal, so that this object doesn't move up or down, okay?
Yeah.
And the horizontal component Tx here, this horizontal component will be equal to the net force, because the vertical component cancels out the weight, equal to net force, and this is the centrifugal force, making it rotate in a circular motion, okay? Centrifugal force, which is mv squared over r. So in your drawing, you just need to draw two vectors, the black vector weight and the red vector tension. And note that the vertical component of the tension is equal to the weight in the length, in the magnitude, okay?
How do you do B? There's no angular velocity or something.
So make an angle, okay. In B, you need to use the information about the angle here, 30 degrees. So you can determine the component of the horizontal force, which is the centrifugal force. Okay, Tx here is the centrifugal force, and it will be equal to the tension multiplied with sine of 30 degrees. But you do not know the tension, but you know the relation between tension and weight, because the vertical component Ty, which is T times cos 30 degrees, will be equal to the weight. So you can determine the tension from the weight, okay? And then plug it into this equation to find the horizontal component, which is centrifugal force. And this force equal to mv squared over r. R is given 0.33 meter, and so you can determine the speed. Okay?
Yeah.
The tension here will be W, the weight, over cos of 30 degrees. So plug it into here, you will have the centrifugal force, Fc equal to weight times sine over cosine, that is tan of the angle, okay, equal to mv squared over r. And from that, you can eliminate the mass from the two sides of the equation, because W weight is mass times G. So V is the square root of G tan 30 degrees and times the radius. Okay, that actually mg, but you divide the mass, so there's no mass necessary. Okay.
Yeah.
And this is the answer. Square root tension sine m. Okay, let's do your calculation and check if it is correct with the mass scheme.
I got 0.785.
The answer is 1.4 meter per second. The same with my equation. G tan times R. G 9.81.
Oh.
R is radius 0.33 and tan.
Yeah. Oh yeah, I got 1.36. Which
Okay.
is 1.4.